Okay, so analysis of variance or the one-way ANOVA, no? Actually, our presenter earlier, no, give some examples of in Microsoft Excel use in ANOVA, no? So analysis of variance or ANOVA is analysis tool used in statistics that splits, no, an observed aggregate variability found inside a data set into two parts, no, the systematic factors and the random factors. So the systematic factors have a statistical influence on the given data set while the random factors do not. So analysis or analysts use the ANOVA test to determine the influence that independent variables have on a dependent variable in a regression study. I think you are also familiar with the t-test and c-test methods developed in 20th century were used for statistical analysis until 1918. Okay, so ANOVA is also called the Fisher's analysis of variance. No, maybe somebody heard the word Fisher analysis of variance. No, and it is extension of the t-test and c-test. So the term became well known in 1925 after appearing in Fisher's book, no, the statistical methods for research worker. It was employed in experimental psychology, later expanded to subjects that were more complex. Now, so maybe what does the analysis of variance reveal? No? Or what we are looking at with analysis of variance? The ANOVA test actually is the initial step in analyzing factors that affect a given data set. So once that test is finished, an analyst perform additional testing on the methodical factors actually, no, that measurably contribute to the data set's inconsistency. So the analyst utilized an ANOVA test results in a F-test to generate additional data that aligns with the proposed regression model. So again, the ANOVA test allows a comparison of more than two groups at the same time to determine whether a relationship exists between them. So the result of the ANOVA formula, the F statistics, or also called F ratio, actually allows for the analysis of multiple groups of data, determine the variability between samples and within samples. If no real difference exists between the tested groups, which is called null hypothesis, the result of the ANOVA's F ratio statistics will be close to 1. So the distribution of all possible values of the F statistic is the F distribution, and this is actually group of distribution functions with two characteristic numbers called the numerator degrees of freedom and the denominator degrees of freedom. So I will show you a video presentations on how we'll be able to use Microsoft Excel in computing ANOVA.
Do one-way ANOVA in Excel. So I've set up this little example over here, and as you know from your studies, in ANOVA we want to compare the three groups in this case, but it could be anything more than two groups, two or more actually, but it becomes very useful when it's actually three or more, when you can't do a two-sample t-test anymore. Okay, so here I have three groups. I have group A, and here are the observations. I have 10 observations, and here I have group B, 10 observations, and group C, 10 observations. So these are called, A, B, and C are called groups or factors when we're talking about ANOVA. And ANOVA itself stands for analysis of variance. So as the name implies, we want to analyze the variance of these three groups, and we want to determine whether these three groups are different from each other or if they're the same. And we measure that along the lines typically of the mean. We want to see if these three means are equal, or whether one of them is not equal to the other two, or in other words, at least one inequality. Okay, so let's calculate some basic figures here. Let's get the sum in each group using the sum function. And let's also get the average. Okay? So basically, these are just some descriptive statistics of our groups or factors. But we're going to use, for in this video, the analysis tool pack that you can get in the add-in section in Excel. So if you don't know how to get that add-in, watch my video on installing add-ins. So it's called Excel add-ins. So make sure to watch that, and I'll try to link that within this video. So we go to data and over to data analysis. Now I've already installed it. Once you've installed it, you'll get this. And here you have all the analysis tools that the analysis tool pack gives us. And since this is a one-way ANOVA, we're going to choose ANOVA single factor. Click OK. And the input range is actually going to just be our 3 groups. And you can take the header column in with that, and you just have to say labels in first row if you take the labels in. In our case, our labels are A, B, and C. And we're grouped by column because our groups are in columns, right? If they were going the other way, it would be grouped by rows. Okay? And then the alpha level you want to set. Typically, by default, it's 0.05, but you can change that to 0.01, 0.1, whatever you need. And here you can choose the output range. Make sure to click in here. And I'm just going to put it on the same page so we can see this right next to our data. Click right there, and let's click OK. Now Excel will calculate all these figures for us, including the summary statistics that we just computed manually here. So you see these sums over here match up with these sums over here, and there's 10 observations in each group, and there's 10 observations in each group, and these are the groups, right? And here are the averages, and here are our averages, right? Everything matches up. We could even have calculated variance here if we like, right? We could just use the equals var function, and you see our variance already is matching up with the variance that solver has provided us. So here, this area is just a summary, as its title suggests. Okay, those things we know how to calculate. Real important stuff is the ANOVA table. Okay, and that's over here. The ANOVA table is going to give us the sum of squares, the degrees of freedom, the mean squares, and our F statistic, p-value for our test, and also the F critical value. Okay, so what are these? Well, between groups, sum of squares is this guy right here. So this is telling us the sum of squares between these groups. Okay, and then within groups, sum of squares is telling us the sum of squares within each group. So you've seen these formulas, so we'd get the sum of squares within each group using the formulas provided, and then we'd add those up. Roughly speaking, of course, because this is an Excel video, the actual computations of it and how to do this manually, I'm actually doing a video on how to get this output by yourself using the formulas that you've learned in your statistics course. But in this video, we want to use the analysis tool pack, so we're just quickly referencing what these things are, identifying those things. Okay, so we have the two sum of squares, which if you add them up give you the total sum of squares, correct? So we have SSW, some textbooks use, right? And SS between, or some books might also call this between or among. I've seen among, but let's just use this terminology, between. B for between and W for within. Okay, if you add these up, this is equal to SST, total sum of squares, right? Total sum of squares is basically the sum of squares if you were to treat all three of these groups as one group and you got the sum of squares. Okay, next, the degrees of freedom. Well, the degrees of freedom for each one of these guys. Okay, so for between, it's number of groups, k minus 1. And since we have three groups, it's 3 minus 1. And for the sum of squares of within groups, it's I believe it's k times n minus 1. So if there's three groups and there's 10 in each group minus 1, we get 3 times 9, and that's 27. Okay? And then this one, just like before, is the sum of those two degrees of freedom. Now the mean square column is simply the sum of squares column divided by the degrees of freedom. And that would give you this number. And same thing for this. It's this number divided by this number would give you the mean square. Okay? And then the F statistic is the mean square between, to distinguish this mean square number over here with this mean square number over here. It's the mean square between, so this guy, divided by this guy, mean square within. And then you would get this guy. Okay? Now, the p-value, which is probably the most important cell in this whole output, this is basically going to tell us whether we accept our null hypothesis or not. And remember, our null hypothesis is, HO is that mu A for group A equals mu B, the true mean for group B, equals mu C, the true mean for group C. And HA, our alternative hypothesis, is that there's at least one inequality. That's what that stands for. At least one inequality. Okay, so just think about that. That means at least one of these is different than the other ones. Okay, at least. Let me just complete this. Okay, so that's our null and our alternative. And of course, we have our assumptions when we do ANOVA, right? That all the observations are coming from a normal distribution, that these three groups have equal variances, in which case this one actually might be different than the other two, but there's other tests like the Levine's test to determine that. And so you gotta make sure your assumptions are met, and then you can go ahead with running the ANOVA. And when you get your p-value, you can now, back to our table here, you can determine that whether you accept or reject the null hypothesis. And in this case, our p-value is not less than the alpha of 0.05, so we accept HO. Or if you want to be very technical, we do not reject HO. Okay, that's saying almost the same thing, but this one is actually more technically correct for sticklers out there. Okay, and then the critical value, just to understand every piece of output here, is actually the value which beyond this is the value on the F distribution. If I could draw a little mock F distribution starts at 0. It's all positive values, and it kind of looks like this. It's got a right skew, got a long right tail that goes on for a while. And this critical number is some number which Excel gives us, 3.35, right? That's just from right here, such that any number greater than this would cause us to reject. Okay? Any number greater than this critical number that we're given here would be a would cause us to reject HO. Okay? So this is, you could say, rejection region, right? If you've learned it that way. Okay? And how does that relate to us? Well, we look at our F statistic, right? And we see where does it fall in relation to this critical. Well, our F statistic will fall well to the left of that, okay? 0.449 is well to the left of 3.35. So obviously it's not in the rejection region, so we do not reject, and we get the same conclusion as when we use the p-value. So it's just two ways of making a conclusion on our null hypothesis here. Okay? So I hope this was helpful. This was a one-way ANOVA, and we used the analysis tool pack. I didn't want to get too involved in the mathematics or the statistics of ANOVA, but we did briefly go over some of the stuff. Some things were left out, but I think generally we got a full picture of how to do a one-way ANOVA in Excel.
Okay, so again, a research might, for example, test students from multiple colleges to see if students from one of the college consistently outperform students from the other colleges. So in a business application, a research and department researcher might test two different processes of creating a product to see if one process is better than the other in terms of cost efficiency. So the type of ANOVA test used depends on a number of factors. It is applied when data needs to be experimental. So analysis of variance is employed if there is no access to statistical software, resulting in computing ANOVA by hand. So it is a simple to use and best suited for a small sample. So with many experimental design, the sample size have to be the same for the various factor level combination. So ANOVA is helpful for testing 3 or more variables. It is similar to multiple to sample t-test. Now, however, it results in few type 1 errors, and it is approximate for a range of issues. So ANOVA groups differences by comparing the means of each group and includes spreading out the variance into diverse sources. It is employed with subjects, test groups, and between groups, and of course the within groups.